Good morning, all of you. My name is Saikiran. I'm your chemistry lecturer. If you remember, in our last class, we discussed quantum mechanical model of atom and detailed explanation of quantum numbers. Today, we shall be discussing about shapes of atomic orbitals. We know that the shapes of atomic orbitals, s orbital in spherical in shape and p orbital dumbbell in shape, d orbital double dumbbell in shape. Now the question is how these shapes of orbitals are discovered. Let's understand. In our last class, we discussed one equation, that is Schrodinger's wave equation. In this, these x, y, z's are Cartesian coordinates. For better understanding, these Cartesian coordinates are replaced with polar coordinates. They are r, theta, phi polar coordinates. I think all of you know what is Cartesian coordinates and what is polar coordinates. Let's understand. This is x-axis, this is z-axis, and this is y-axis in three-dimensional space. In this, let's assume this is a point. It is x, y, z. These are called Cartesian coordinates. And when I am drawing a line from origin to this point, the radius is r. And this line makes an angle with z-axis in an anti-clockwise direction. This is theta. And let's assume an imaginary line of this line in xy plane, that is like this. This imaginary line makes an angle with x-axis in anti-clockwise direction is phi. These are called polar coordinates. And these are expressed as r is capital R and theta with capital theta and phi with capital Phi. These are divided into two parts. This is called radial part. And this part is called angular part. Let's see what is the use of this radial part and angular part. The first one is radial part. It gives the information about electron density around the nucleus, and also it gives the information about nodes, particularly radial nodes. Let's understand. Now, this R is called radial probability. We already discussed in our last class. For example, this is nucleus and this is electron. The probability of finding electron from certain distance from the nucleus is called radial probability R. And let's understand. X-axis, Z-axis, Y-axis in three-dimensional space. This is the radius R. Now, I am moving this radius R in all directions. It gives me information about where the electron density is present. And I am increasing the radius and moves in all direction. It also gives the information about electron density present in this region. In this region is electron density is more, and this region electron density is more. In between these regions, there is no electron density present. That is called node. Node is nothing but the maximum probability of finding electron density is 0. There is no electron is present. That region is called node. This is also called radial node. Now come to the angular part. This angular part depends upon L and M values, and these radial parts depend upon N and L values. This angular part gives the information about shapes of orbitals. Let's understand. These are x and y axis, x, y, z axis in three-dimensional space. This is the angle theta. When this angle moves in all direction, now this comes this. At this place, there is no electron density present here up to here. And it comes this side, some electron density is present here. And this moves in this side, there is no electron density present up to here. And moves this side, there is no electron density present here. Moves this side, there is no electron density. Moves this side, some electron density is present here. And moves this side, there is no electron density present here. Moves this side, no electron density present here. Based on this electron density, by drawing a line combining with nucleus, it gives the shape of orbital. This is dumbbell in shape. And similarly, jet plane, this angle moves in all directions. It gives the electron density. This is present in spherical shape. This is dumbbell shape. This is the radial part and angular part. Based on these two, we get the information about electron density and nodes and shapes of orbitals. Now come to our actual topic, shapes of atomic orbitals. Now, what is the orbitals? What is the basic definition of orbitals? It is nothing but the space around the nucleus where the probability of finding electron is maximum. In this case, this is called orbital. In this case, this is the probability of finding electron maximum. So this is called orbital. This is also called orbital. It is represented as like this. The maximum probability of finding electron in orbital is 95%. That's why we mentioned the probability. And the shapes of orbitals are designated based on azimuthal quantum number. Let's see. The first one is s orbital. If L value is 0, it designated as S subshell. For this, M value is 0. It is represented as S orbital. The shape of S orbital is spherical. Spherical in shape. That is, this is the non-directional orbital. As energy of S orbital increases with increasing the n value. That is, 4s is greater than 3s, greater than 2s, greater than 1s. This is about S orbital. Now come to the p orbital. If L value is 1, it is designated as P subshell. And for this, M values is -1, 0, +1. These are designated as Px, Py, Pz. Let's try to draw these orbitals. X, Y. This is the Px orbital. This is Py orbital. And this is Pz orbital. The shapes of p orbitals are dumbbell. These are degenerate orbitals. What is the meaning of degenerate? It is nothing but the energy of these three orbitals are equal. The same energy of orbitals is called degenerate orbitals. The energy of p orbitals increases with increasing the n value. For example, 4p is greater than 3p, greater than 2p. And these p orbitals are oriented along the axis. This is about p orbitals. Now come to the third one, d orbitals. If L value is 2, it is designated as d subshell. For this, m values are -2, -1, 0, +1, +2. These are represented as dxy, dyz, dzx, dx square minus y square, dz square. Let's try to draw all these structures. This is called dxy orbital. This is dyz orbitals. This is dzx orbital. This is dx square minus y square orbital. This is dz square orbitals. These are also degenerate orbitals. The energy of these pi orbitals are equal. And the dxy, dyz, dzx orbitals are oriented in between the axis. And this dx square minus y square dz square orbitals are oriented along the axis. In this dz square, it contains a ring-like structure. This is also electron density around the nucleus. This is about d orbitals. Now come to the f orbitals. The d orbital shape is double dumbbell. Fourth one is f orbitals. If L value is 3, it is represented as f subshell. For this, m values is equals to -3, -2, -1, 0, +1, +2, +3. The shapes of f orbitals are complicated. We no need to draw these structures. That's it about shapes of atomic orbitals. Now come to the second topic, node and graphs related to psi versus r and psi square versus r. Now what is this node? Node is nothing but the space around the nucleus where the probability of finding electron is 0. Let's see, we have two types of nodes. One is radial node. It is also called as spherical node. And second one is angular node. For radial nodes, we have a formula that is n minus L minus 1. And for calculating angular nodes, that is equals to the L value. Let's see the example. For 1s orbital, radial nodes is equals to 1 minus 0 minus 1, that equals to 0. There is no radial nodes present in this 1s orbital. And angular nodes is equals to L value, that equals to for s orbital 0. There is no angular nodes present in this 1s orbital. Let's see. This is nucleus and this is the 1s orbital. And graph, let's see the graphs related to 1s orbital. Psi versus r, psi square versus r. This 1s orbital graph like this. Now come to the second example, 2s. For 2s, radial nodes is equals to 2 minus 0 minus 1, that equals to 1. And angular nodes is equals to L value, that equals to 0. Let's see. This is the nucleus. And this is the 1s orbital. And this is the 2s orbital. This region is called radial node or spherical node. Let's see the graphs related to 2s orbital. Psi versus r. This graph is psi square versus r. This graph like this. This point represents the probability of finding electron 0, this region. That is called radial node. And psi square graphs looks like this. This point represents this area, node. Now come to the next example, 3s. For 3s, radial nodes is equals to 3 minus 0 minus 1, that equals to 2. And angular nodes is equals to L value, that equals to 0. Let's see the diagram. This is 1s orbital. This is 2s orbital. This is the region of 3s orbital. And this part are called radial nodes. Let's see the graphs related to 3s orbital. This graph is psi versus r. This is psi square versus r. We know that psi have positive values and negative values. For that, graph like this. This part and this part represents the radial nodes. And this part of peak represents the negative value of psi. And these two are positive values of psi. For psi square, only positive values is there. For that, graphs like this. These 2 points are represent the radial nodes. Now come to the next example, 2p. 2p orbital. For 2p orbital, radial nodes is equals to 2 minus, for L value for p is 1 minus 1, that equals to 0. There is no radial nodes present in this 2p orbital. And angular nodes is equals to L value, that equals to 1. One angular node is present. Let's see. This is the nucleus. And p orbital shape is dumbbell. The angular node looks like this. This is called angular node. It's passing through the angle. Let's see the graphs related to 2p orbital. Psi versus r. Psi square versus r. This graph looks like for s orbitals, graph starting from the higher point. And for p orbitals, d orbitals, graph starting from the origins, like this. For psi square versus r, like this. This is the 2p orbital. Now come to the next example, 3p orbital. For 3p orbitals, radial node is equals to 3 minus 1 minus 1, that equals to 1. One radial node is present. And angular node is equals to L value, that equals to 1. This, like this. This is the orbitals. This is the electron density. This represents the radial node, and it is also have one angular node. This is angular node. Let's see the graphs related to 3p. Psi versus R. This is psi square versus R. This graph like this. This point shows the radial node. This is the psi square versus R graph. Now come to the nodal planes. It is nothing but the plane which is probability of finding electron is 0. It is also called as angular node. Let's see. For orbital, L value, nodal planes. For s orbital, L value is 0. It has nodal planes are 0. And for p orbital, px, L value is 1. It has one nodal plane. This is z axis, y, x. This is the xz plane, where the probability of finding electron is 0. This plane is called nodal plane. On this plane, there is no probability of finding electron. This plane like this. For py, L value is 1. It has one nodal plane. Like this. This is y-axis and this is z, this is x. This is yz nodal plane. This is xz nodal plane. For pz, L value is 1. It has one nodal plane. That is like this is z, this is y. xy nodal plane. For dxy, it has two nodal planes like this. This is x, this is y. In this, z-axis is also there. These two nodal planes are along zx and yz. For dyz, two nodal planes is there. They are xz, yz, xz, xy. For dzx, two nodal planes is there. They are yz, xy. These are the nodal planes present in these orbitals. Let's see few more orbitals. Next, dx square minus y square orbital. It has L value 2. It has two nodal planes. Let's see. X square y square like this. Double dumbbell shape. It has two nodal planes. And another nodal plane is like this. These two nodal planes are like this. For dz square orbital, it has two L values, so two nodal planes. But dz square orbitals, there is no nodal plane present. Let's see. This is the dz square orbital. In this, one ring-like structure is there. This is also electron density. For this, there is no nodal plane present in this dz square orbital. But in case of dz square orbitals, two nodal surfaces is there. This is also called conical surfaces. In this, probability of finding electron is 0. This is the nodal planes. That's it today class. In our next class we will discuss electronic configuration.